Have you ever wondered how batteries power our devices? These small yet mighty components are essential in our daily lives, from our smartphones and laptops which we use for communication, work and entertainment, to even electric cars that are revolutionizing the way we travel. These tiny powerhouses rely on the fascinating world of electrochemistry. They work through chemical reactions to provide us with portable energy. Inside each battery, a series of chemical reactions occur, converting stored chemical energy into electrical energy. It's like magic, but it's really science. The principles behind these reactions are rooted in basic chemistry, yet they power some of the most advanced technologies we use today. These amazing devices are called electrochemical cells. They come in various types such as lithium-ion, nickel-cadmium and lead-acid, each with its own unique properties and uses. Let's dive in and learn more about how these incredible cells work and the science behind them. Electrochemical cells are like tiny factories that convert chemical energy into electrical energy or vice versa. These cells are fundamental components in batteries, fuel cells, and even some types of sensors. They play a crucial role in powering our everyday devices from smartphones to electric cars. They have two main parts, electrodes and electrolytes. The electrodes are the sites where the chemical reactions occur, while the electrolytes facilitate the movement of ions within the cell. Electrodes are materials that conduct electricity and participate in chemical reactions. They can be made from various materials, including metals, carbon, and even some types of polymers. The choice of electrode material can significantly affect the efficiency and performance of the electrochemical cell. There are two types, anodes and cathodes. The anode is where oxidation occurs, meaning it loses electrons, while the cathode is where reduction takes place, meaning it gains electrons. This flow of electrons between the anode and cathode generates the electrical current. Electrolytes are solutions that allow ions, which are charged atoms, to flow between the electrodes, completing the electrical circuit. These ions are essential for maintaining the balance of charge within the cell, ensuring that the chemical reactions can continue to produce electrical energy efficiently. Electrolytes can be in liquid, gel, or solid form depending on the type of electrochemical cell. Galvanic cells, like the batteries we use every day, produce electricity through spontaneous chemical reactions. Imagine the common Daniell cell. It has a zinc anode and a copper cathode, each immersed in a solution of their respective ions. When connected, zinc dissolves, releasing electrons that flow through the circuit to the copper electrode, generating electricity. Section 4. Electrolytic cells, reversing the flow. In this section we will explore the fascinating world of electrolytic cells and how they differ from galvanic cells. Electrolytic cells work oppositely to galvanic cells. While galvanic cells generate electrical energy from spontaneous chemical reactions, electrolytic cells require an external source of electrical energy to drive non-spontaneous reactions. They use electrical energy to drive non-spontaneous chemical reactions. This means that the reaction would not occur on its own without the input of electrical energy. Water electrolysis is a great example. In this process, water is decomposed into oxygen and hydrogen gas by passing an electric current through it. By passing electricity through water, we can split it into hydrogen and oxygen gas. This process is not only fascinating, but also has practical applications. This process has important applications in fuel cell technology and other industrial processes. For instance, hydrogen produced through electrolysis can be used as a clean fuel in hydrogen fuel cells, which are being developed for use in vehicles and other technologies. Section 5. Comparing the two similarities and differences. Both galvanic and electrolytic cells involve redox reactions, where electrons are transferred between chemical species. However, they differ in their spontaneity and energy conversion. Galvanic cells spontaneously convert chemical energy to electrical energy, while electrolytic cells require external electrical energy to drive chemical reactions. Section 6. Electrochemical cells in our world. Electrochemical cells are everywhere. They power our portable devices, enable electroplating for shiny jewelry, and protect structures from corrosion. Water splitting through electrolysis has the potential to revolutionize clean energy production. Scientists are constantly working on improving these cells for a more sustainable future. Section 7. Keep exploring. From powering our devices to producing clean energy, electrochemical cells play a vital role in our lives. Understanding how these tiny powerhouses work opens up a world of possibilities for technological advancement. Keep asking questions, stay curious, and never stop exploring the wonders of science.